Good day, good people. Welcome to JJ Tech Tutoring. In today's video, I'll be taking you guys through the block diagram reduction rules and examples. So I'm just gonna give you 4 to 5 rules, actually 5 rules, and then from there I'm gonna then do an example for you, right? Then let us get into the business. All right. Then the first rule that I would like to share with you will be the first rule will be a feedback closed loop rule, right? Right, so I'm just gonna use R and C, right? So I'm gonna use R on my input and C on my output. So that's how we're gonna be working. Some will use X and Y. It's nice, right? But then now don't confuse the two. You can use X and Y, and you can also use R and C, right? Then R S, then this sign, it's called summation or adder. You can call it adder, you can call it summation, right? Then G of S into is C of S. Why did I say closed loop? You guys now understand. Closed loop and feedback, you guys now understand, because I have done the introduction to control systems, I've done the introduction to open loop and closed loop in the same series, right? Now this is our feedback, right? So automatically you now know that this is a negative feedback or negative closed loop. Why? Because there is negative here, because there is negative here. Then how do we reduce this circuit, right? Because the main idea of this video is to teach us the reduction rules. So why do we need reduction rules? So that we can be able to reduce our circuits into simpler circuits, right? Now let us then reduce this circuit, right? Let us then reduce this circuit. We're gonna have our RS reduced, and that means we only left with only one box now. Then what do we do to the box? We take our gain is G of S as the numerator, and divide it by 1 plus G of S multiplied by the feedback gain, right? That's it, right? Then obviously if you're observant enough, then you will question, or why do we have positive and negative? That's the rule, right? So you will see when we then go to a negative feedback rule, right? So this is this is negative feedback rule. Then we're gonna go to the positive to positive, right? So this one is positive to negative, then we always use positive, right? Now that is our first rule. Then second rule, it will be feedback closed loop, and then this one will be positive, right? Then we're just gonna write our RS into, we add summation, and then positive. Then from there we have our gain G of S, then it goes to C of S, right? Then from there we're gonna add, right? Take the feedback H here, right? H of S, and then what do we do? Then we have to reduce it, right? So when reducing it, RS into, then we take our bigger gain, and then CS, right? Now what do we do now? We have to take the numerator, it's our GS, and denominator will be 1 minus G of S multiplied by gain of the feedback, right? As simple as that, right? Now we're gonna go to the third rule, which is series or cascade, right? Then that means there will be RS, this is our open loop, right? G1, G2, and then CS, right? Now how do we then reduce this one? Because as the topic says, block diagram reduction rules, right? So how do we reduce this now, right? So To reduce this, it's just RS, then we have 1 again, right? CS, right? So what do we put there in? We put G1 multiplied by G2. That's how we then deal with this. As simple as that. Series, we multiply, we multiply the boxes that are in series. Multiply the boxes that are in series. Now, can we then prove it? Because sometimes we, engineering students, we love proving stuff. So let us prove it. Let us prove and see. RS and this box, and then another box, and then we go to our output, which is CS, right? So G1 and G2. So basically, the output of this circuit is C over R, right? This is the output of this circuit. It's this over this. That's the output. We together on it, right? Now, let's say we introduce the output of block 1, right? And say, let's say this output is X, right? Let's say this output is X, right? Then what is going to be the output of block 1? Yes, the output of block 1, it's going to be the output of block 1 to be G1 is equals to X over R. We're together on that. Then what is it that is going to be the output of G2? Because now this is the output of G1, and it being the output of G1, it becomes the input of G2, right? So that means G2 is equals to it's equals to C over X, right? Then what is the output, or what did we say will be the output, or will be how we're gonna solve series? You are right. We said it will be it's gonna be G1 multiplied by G2, right? So what do we do now? We say G1 multiplied by G2, that means it's X over R multiplied by C over X, and then this cancels this, and then the final answer will be C over R. What is the output of the entire block? Didn't I say it will be C over R? So what is this? So that means this actually emphasizes that the rule is Q, right? So you can just forget about this. This is not as important as knowing exactly this. So here I was just proving it to you. Right, now we are going to the parallel. So that means it's the fourth rule. We're going to the parallel rule. So when blocks are connected in parallel, right? That means their individual gains should be added, right? Now, RS into this block, and then we have our gain here, and then we have our summation here, or adding, and then, and of course we have our output, which is C, right? Then, as you have had, this is easy, right? So this is our takeoff point, right? This is our adder or summation. This is our takeoff point, right? So this is basically our parallel, because this RS here is connected to this one, and then again this takeoff point connected this. So this makes this parallel because they also came here and connect here. This went there and connect here. So this makes the two parallel, right? So what do we do to this one? We just say what? To reduce this one, easy, is G1 plus G2, right? R and C, right? So engineering students, we love proving stuff. So what did we say about series? This R here, this R here is in series with this one. This R here is in series with this one. So that means the total here, C is equals to RG1 plus RG2, right? Because we said in parallel we add them, right? So we are adding this one and this one, but we just want to see what's gonna happen, right? When we say this multiplied by this plus this multiplied by this. So obviously we're gonna have the common factor of R, and then it's G1 plus G2, right? Then from there, C is equals to RG1 plus G2, right? Then from there, when we take this R to that side, we divide by R, So the answer will be C over R is equals to G1 plus G2. What did I say about the overall output? The overall output of these blocks, right, are always this one divided by this one. So that means that makes this correct. That makes this correct. As I told you here, that the output will be this one over this one, right? So that makes this correct, right? Now we're going to come to the very interesting rule, right? That means it's number rule 4, right? It's not rule 5, right? So we are going to a shifting of takeoff point, right? So in the shifting of takeoff point, we will be shifting this from this point. We'll be shifting from this point to this point, right? Now that means we have to redraw the diagram, right? We shifted the point, right? This point, right? So what is it that is going to be the output here? So automatically, because it's just the same line, so that means this will be R. But sorry, this was the output was RG. So was RG. So the output of this one is RG. So we can just put RG here. So that means we are taking this side, right? This side, right? Now, how do we then take this side? Since the output of the in the left hand side is R, then the rule says the output of a takeoff point must be the same before and after takeoff point, right? So this should be the same before and after, right? So that means here in this R we should have RG. So what is it that we can do to end up with RG, right? So we then need to add another box. Where do we need to add another box? We need to add another box this side, right? So that means our other box is gonna be like we've got R here, and then let's have a box here, right? Just leave this as it is, and then this, right? So after having this box, then you see that okay, the output will be RG. I've added this box in series because series is the one that actually allows R times G or multiplication. So this output here is just exactly the same with this output. So this circuit were reduced from this one to this one, or changed from this one to this one. So the point changed. The point changed from this one to this one, right? So that's it, right? Now let us check the one that is going to be changing after the block. So that means it will be going from this side to this side, right? Now let's go. Let's say we're given a block like this. Now man, G, C, right? And this C of course is RG, right? So we need to take this point from this point to this point. We need to move this point. So we're then going after the block. So what is it that we're going to do? We have to take this side. So that means it's going to be R will remain alone without a point, and it's go that side. Here we're going to still have our C, which is RG, and then here of course it should be RG as well, right? Because we haven't introduced this side. Now we need to then end up with an output of what? Of R, right? The output should be an R. So what do we do to this line to end up with an R? We have to add a box that is, or that contains 1 over G. Why? So that this box will be in series with this one, and they're gonna just multiply. After they multiply, then they're gonna cancel out and give us the output of an R. Since this side it was R, so when it moves to this side it should be R. So what do we do now? Let us then draw the block diagram in a good way. Right, now C is equals to RG. Then here we will be having this RG, that is C, and then we're gonna add a box of 1 over G, and then the output will be R, because we're gonna add these two, and it will be RG multiplied by 1 over G. Then this one will cancel and we'll have R. So basically this is how to move or to shift the box, right? So that brings us to the end of this tutorial. Then The tutorial that comes after this, it will contain the example, right? We'll be solving the example. So just don't forget to subscribe and hit the bell icon, because I'll be always releasing videos about control systems, right? Now let's go to tutorial that follows. That will be solving the problem.